CDF. When do we use a CDF? Or when do we use a PDF? Let's start that first.
Wait, tell me PDF and I can tell you CDF.
All right, so let's go.
At most is PDF.
Try it again.
No, CDF and then equal is PDF.
Good. Thank you. Let's listen up. Here. When we talk about the binomial, there's two functions in our calculator. The binomial PDF. We use the PDF when we have the words equal to. We use the binomial CDF when we have the words that are less than or equal to. And so, listen, the calculator has both these functions, and we can calculate those. The problem with that is we're missing a function now, and we need one for the at least case. And the at least case is going to be something that looks like this. It's the probability that x is greater than or equal to something. At least means you're greater than or equal to. So we need a function for that. And here's how we're going to handle it. Look at the example. It says a survey indicates that 41% of women in the United States consider reading as their favorite leisure time activity. You randomly select 4 U.S. women and ask them if reading is their favorite leisure time activity. I want to create a binomial probability distribution for the number of women who respond yes. So here's how this works. Is this case binomial first off? Do we have a probability of success and failure? No. Yes. What's the P? 41. What's the Q? If they don't like it, then the failure would be what percentage? 59%. You understand that? Do we have a fixed number of trials? Or a fixed number of women that we're looking at? Do we have a fixed number of women we're looking at?
Oh, 4.
Yeah, so here's what we have. We know that X follows a binomial distribution with an N of 4 and a P of 0.41. And here's what we're going to calculate next then. From this, we're going to find the number of women. So how many women can actually respond to this? What's the smallest number of women that can respond yes?
1.
No, try it again.
0.
0. Actually, the smallest number is 0 up to the largest number, which is what?
4.
4. All right. And so what you're going to do is this now. You're going to calculate the probability that x is equal to 0. The probability that x is equal to 1. Probability that x equals 2. The probability that x equals 3. And the probability that x equals 4. So we're calculating all these probabilities of the equal. So what function do I use? CDF or PDF? PDF. So I'm going to leave the function like this. Binomial PDF. The n for all these will be 4. Probability of success will be 0.41. You're going to change your x to whatever the x is. What I want y'all to do is go ahead and calculate those values, please. Go ahead and calculate all 5 of those values now. 0, 1, 2, 3, and 4. So here are the values we get. And notice this. What should those values add up to? Let's verify they add up to 1. So we have 0.121 plus 0.337 plus 0.351 plus 0.163 plus 0.028. And we get a total sum of 1. Do y'all see that?
Why is it perfect?
Because we rounded off correctly for each value. It should be perfect. So now that we have these values here, let's go answer some questions with these values, all right? And the first question says this. Using the table above, find the following. That no women like reading as their favorite leisure time activity. So first off, what is that x going to be equal to then?
0.
0. So the probability, write it like this, that x equals 0. And from this table, we see that probability is equal to what? 0.121. 0.121. The next question says, or better yet, before we continue, how would you do this in your calculator? This is just what? This is the PDF, right? This is binomial PDF. This is binomial PDF. Your n is 4, your p is 0.41, your x is 0, right? The next one, how do you do that one? That would be the probability that x is
Equal to, greater than or less than or equal to 2, sorry.
good. So the next one would be the probability that x is greater than, or I'm not greater than, but actually less than or equal, right?
CD.
At most 2 means less than or equal to 2. So we go in our table, at most 2 means what? At most 2 would be 2 or less. So you'll be looking at anything that's above this green line, right? Like this.
So you add them.
So you would add up those values, 0.121, 0.337. So 0.121 plus 0.337 plus 0.351. I get 0.809. So this value right here is just 0.809. Now, that's what the calculator is doing as well, right? And in the calculator, what we type in here? Instead of doing the PDF, we're going to do a what? A CDF, right? And it's 41. Thank you, 0.41. And then this time it'll be a 2. Our x is 2. So if you do that second vars, binomial CDF, 4.41 and 2, you get the same value, 0.809. Do y'all see that? So we have functions for those two. The next question says, what is the expected number of women to like reading as their favorite leisure activity? How do you find the expected number? What does it mean to find the expected number? That means find the mean. Good. When you find the expected number, the mean, we call it the expected of x, like this. It's also mu of x. So listen again. Listen. When you find the mean, mu of x, here's what you're doing. Let's figure out a simple binomial situation. If we take a coin, and we're interested in the number of heads that come up when we flip the coin. If we flip that coin 100 times, how many heads do you expect to get? Why do you expect to get 50 heads? 2 outcomes means there's a 50% chance for each outcome, right? How many times are you actually doing the activity? 100 times. So you should get how many heads? 50. What you've done is you multiplied the probability of success times the total in the sample, right? So how many do we have here in our sample? We have 4 people in our sample, right? Times the probability of success is what? 0.41. So we do 4 times 0.41 and we get 1.64. To calculate the expected number, or the expected value, this is just n times p. N times p is the expected value. If actually for the standard deviation of x is equal to the square root of n times p times q. So if actually for standard deviation is square root of npq. Now, the last part says that at least one woman likes reading as her favorite leisure activity. So in this case, what does at least one mean? At least one means that it can be greater than or equal to 1, right? When we go back to our table, if we're greater than or equal to 1, who are we?
0 or 1.
If we're greater than or equal to 1. 1, 2, 3, and 4. It's all these people right. It's all these right here, right? Do y'all see that? Now, the calculator cannot calculate that. The calculator does not know how to calculate that. But we can trick it into calculating it by doing what? Well, we know that all these values have to add up. All of these values together have to add up to what number? 1, right? And I know that I just want this part of it, right? This purple part. Everybody understand that?
Subtract the 0.121.
Good. So we're going to subtract the 0.121 from 1. So we know we can do this. Then here's what it's equal to. This is equal to 1 minus the probability that x is. When I say at least 1, that's everybody except 2. That's everybody except 2. At least 1 is everybody except 0. So this is 1 minus the probability that x is less than or equal to 0. That's how you're going to write that. When you calculate at least 1, you're doing 1 minus the probability that x is less than or equal to 0. So this is just 1 minus binomial. Less than or equal means you're using a CDF. What's your n? What's your n?
4.
It's still 4. Probability of success is 0.41. Your x is what? What's the x right here? You're interested in x4 less than or equal to, not 1, but it's still 0. So 1 minus second vars. Why'd I lose you? What part lost you?
Now you're, I don't know. Because at first you put whatever number it was as x, and now you're putting 0, so I'm confused.
Because why? That's a good question. Listen up. Shh, listen. Hey, don't get confused on this part where I put Normally we put whatever this value of x is right here, we put that in back here, right? That's what you're saying, right? But this time my new x is going to be what? Why am I putting this 0 right here?
Because it's the only one that's open.
It's the only one that's not including for at least 1, right? So I just do 1 minus the probability. It's going to calculate up to 0. That's what you're calculating up to. You're calculating the 0 value.
Okay.
So I'll show you an easier example. We'll look at the next one. Look at example 2. Example 2 says Jose Altuve has a career batting average of .325. If he has 5 at-bats in a game, what's the probability he gets at least 1 hit? Let's change this to 2 hits. Let's change this to a different number. So change this to 2 hits right here. What's the probability he gets at least 2 hits? So, if he comes up to at bat 5 times in a game, and he has a .325 average, right? I want to find the probability he gets at least 2 hits. What does that mean, at least 2 hits out of 5 at bats?
Hits the ball 2 times.
2 times, or it can be actually be what? It can be 2 times, or it can be at least 2 means what? 2 or 3 or 4 or who can it not be? What can it not be? 1 or 0. Everybody got that? So when we do this, we're going to say the probability that x is greater than or equal to 2 is 1 minus the probability that x is less than or equal to what numbers?
3.
It can't be, it can only be 2, 3, 4, or 5, right? What numbers can it not be?
1 and 0.
So we're going to be less than or equal to 1. Because less than or equal to 1 includes 2.
0.
0 and 1, right? So in our calculator, what we type in? 1 minus the binomial CDF. Let me do it below it. This is 1 minus binomial CDF. What's your N? 5. What's your P? 0.325. What's your X? This time your X is whatever's sitting next to the less than or equal sign, which is what here? A 1. So you're always going to put that value in, because that's what your calculator can calculate. So 1 minus 1 minus binomial CDF, and then 1 is 0.524. Football team has an 80% chance success rate based on its attempts this year. If its kicks are independent of each other, determine the probability of making at least 1 field goal out of 4 attempts. So we want to make 1 field goal out of 4 attempts, right? Right now he has what kind of percentage of making the field goal? 80%. He's taking how many kicks is he going to attempt?
4.
So X follows a binomial with a N of 4 and a P of 0.8. At least 1. We want to see if he makes at least 1. So at least 1 will be the probability that X is
4.
greater than or equal to 1, right? What does that mean if you're kicking 4 things? You can make 1, you can make 2, you can make 3, or you can make 4. What can you not make?
0.
0. So we do this. This is just 1 minus the probability that X is less than or equal to 0, which is 1 minus binomial CDF. Your N is 4, your P is 0.8, and your X is 0.
Oh, I did that. Okay. I'm confused. When do you use? Huh?
I said give us a test over this point.
Yeah, before I forget it.
Literally.
What's the difference between CDF and PDF?
CDF?
PDF is if it says like equal.
It
So,
probably goes.
okay, on A, you see binomial.
And the answer is 0.9984.